We saw that force and momentum are very closely related. As the change in momentum increases, force also increases. So, with the help of this, Newton gave his second law. So, Newton's second law stated that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. So, according to Newton's second law, the force is directly proportional to the rate of change of momentum. So, a rate of change of momentum can be written as dp by dt. So, force is proportional to dp by dt. Now, again, you must not be aware of dp by dt. Here, a rate of change of momentum means change in momentum per unit time. So that is why you can dp by dt will understand this d by dt in the inshallah in the higher classes. Here, this force you can consider it as the change in momentum, and this force is directly proportional to dp by dt. And it also says that the rate of change of momentum also takes place in the direction in which the force acts. In the previous example, the player catching the ball, you saw this thing. The change in momentum and force, they act along the same direction. Now, since f is directly proportional to the rate of change of momentum, now we can convert this proportionality into equality sign, but for that you have to insert here a constant, and that is k. That constant here is k, and the value of k is taken as 1, and therefore force is equal to dp by dt. Okay, now this dp by dt can also be written as alternatively. The second law is stated as the relationship between an object of mass m, its acceleration a, and the applied force f is given by f is equal to m into a. The direction of the force vector is the same as the direction of acceleration vector. Here f is a vector quantity, force is a vector quantity, and acceleration is also a vector quantity. Okay, and it says that if there's an object of mass m which moves with an acceleration a, then the force acting on that body is given by mass into acceleration. It means force is equal to mass into acceleration. Okay, so here force and acceleration, they both act along the same direction. So the statement f is directly proportional to dp by dt, and now the another statement, that is f is equal to m into a, they both are actually the same. There are two statements, f is equivalent to dp by dt, f is equivalent to m into a. They both are actually the same. They both are synonymous, you can say. So we will try to derive this in next slide, that f is equal to ma. So from definition, we saw that force is nothing but a rate of change of momentum, right? Now you keep this d by dt as it is, okay, aside. Now what's p? Momentum, it's mass into velocity, so I write m into v here. Okay, now this becomes m into dv by dt. Okay, because there is no change for mass, so d by dt will go to velocity. Okay, now what is rate of change of velocity in our previous chapter? Dv by dt means rate of change in velocity. Now we have studied about this in the previous chapter. We spoke about that, which is that quantity which talks about the rate of change of velocity. That is acceleration, right? So acceleration is the quantity that talks about the change in velocity. So keep m as it is, dv by dt, rate of change of velocity is acceleration, so ma. So now this can be written as force is equal to m into a, because we saw that now force is equivalent to ma. And it's nothing but it is another form of writing force is equal to rate of change of momentum. So from Newton's second law, we we found that for any object for which external force F is acting, that F is given by the product of mass of that object and acceleration of that object. So this was Newton's second law, and this law was very, very significant since it became a very general like the first law, it only talk about uniform motion. The second law gave the mathematical relationship for any kind of non-uniform motion. Now, what is the unit of force? According to this, we can say that force can be written as a unit of mass is kg and unit of acceleration is meter per second square. So the unit of force is kg meter per second square. But the SI unit of force is Newton. Okay. Now let's see how is the second law consistent with the first law. Whether the first law and the second law um, are consistent to each other. First law talk only about uniform motion. Now second law is talking about non-uniform motion. Now is the second law applicable for the uniform motion also? Is it a generalized law? Let's look at it. Now see, second law states that force is equivalent to mass into acceleration, right? Now according to first law, if force is equivalent to zero, if the external force acting on the system is equal to zero, then what will happen? According to second law, acceleration will be zero. Then if force is zero, then acceleration will be zero, right? So a is equivalent to zero. What does that mean? Acceleration of body is zero. That can mean two things. One is body is at rest, or the another case is another maybe the body is in uniform motion, right? Because when the body is moving with uniform velocity, acceleration is zero. So we have talked about this in our previous lesson, right? Now, in the second law itself, if the external force is zero, then the body is either at rest or it's in uniform motion. And what is our statement of first law? First law states that if a body is at rest or if the body is in uniform motion, that means if the acceleration produces zero, and then the net acting force on the body is zero. So both of them are telling the same thing. So my second law is consistent with the first law, right? And both are saying the same thing. We can say that second law is true not only for non-uniform motion, but it holds true for uniform motion as well. So the first law and the second law are consistent to each other. Now we will talk about another quantity, that is impulse. Impulse is defined as a force multiplied by time it acts over. That means when force is acting on a body, for how much time the force actually acts on the body. That is known as impulse. So the product of force and time, it acts over. So the product of force and time, it acts over. The time duration for which the force actually acts on the body. So that time multiplied by force gives us impulse. So force is nothing, impulse is nothing but the force multiplied by time. For example, tennis racket striking the ball. So when you strike the ball with the racket for some period of time, the force actually acts on the ball. So that time multiplied by force gives you the impulse. So impulse is also written as change in momentum. Now why do we write that? Because as per the definition of impulse, what is it? It is force into time. So impulse is force into time. But now what is force? From Newton's second law, force is the rate of change of momentum. That is force is rate of change of momentum. That is delta P by T. So time will get cancelled and you will get force is equal to impulse is equal to change in momentum, delta P, right? So impulse is equal to change in momentum. Thank you.